Hello and welcome to Physics with Amol sir. So this video is for class 10th and we will continue with the chapter light. So the previous class we discussed what is meant by refraction. We discussed the laws of refraction. Okay. So I hope you remember the concepts. So basically refraction will take place when light will pass from one transparent medium into another transparent medium. Okay. At the boundary that is separating the two medium, that is where refraction occurs. Now, as I told you, we have not discussed why the phenomena of refraction occurs in too much of detail. Okay, because as far as our class 10th is concerned, this much information is enough. Now, what we remember, okay, that there is something called as optical density. If a material medium is having higher optical density, the velocity of light is going to be lower. Okay, this change in velocity, this is what causes the phenomena of refraction. For now and for class 10th purposes, you should remember this much. Okay, now today we are going to see refraction by spherical surfaces. Okay, specifically we are going to talk about lenses, concave lens and convex lenses. Okay, so let's begin. So we are going to see refraction by lenses. Okay, and we are going to talk about two types of lenses. They are concave lens and convex lens. Okay, here are the diagrams of these lenses. So one you see is a convex lens and the other one is a concave lens. So if you see a concave lens has curved surfaces like this. Okay, you can notice that it is thinner in the middle, okay, and outside it is thicker. And this is a convex lens. A convex lens you will see is thicker in the middle and at the edges it is thinner. Here it is in real life. So this is a magnifying glass. A magnifying glass, it has a convex lens. Okay, a concave lens, I don't have it with me right now, but here is a photograph of a concave lens. Okay, so we are going to discuss these two type of lenses, concave and convex. There are other type of lenses where you will have one curved surface and one surface will be plane. Okay, it's called as a plano-convex lens. Or you can have one surface is concave and the other surface is plane. It is known as a plano-concave lens. There are also lenses where one surface is convex and the other is concave. Okay, they are called as concavo-convex lens. But we are not going to see those cases. For this chapter, we will be focusing only on these two type of lenses. Okay, this is actually called a double convex lens and this is called as a double concave lens. But for purpose of our chapter, we will simply call this as convex and we will simply call this as concave. Okay, so first these two shapes should be understood. You should be able to look at the diagram and you should be able to identify whether it is convex or whether it is concave. So once again, if in the middle part it is thick, it is convex. If in the middle part it is thin, it is concave. Okay. Now let us understand the shapes and diagrams for these two types of lenses. Okay. So here is a convex lens. Now I am sure you remember that for a concave mirror and convex mirror, we calculated the focal length and the radius of curvature. So we have a focal length in case of lenses as well, but there is no concept of radius of curvature. Remember. Now let us see first the diagrams and how we are going to have the measurements on this. Obviously this dotted line, this denotes the principal axis as before. The center of the lens, that we denote as O and it is called as the optical center. Okay, so O is the optical center. So for convex lens it is here and for concave lens it is here. Fine, that is the optical center. Then as we said, it will have focal points. But a concave mirror and convex mirror, it had only one focal point. But in case of lenses, there are two focal points. Remember, so lenses have two focal points. So for a convex lens, it will have one focal point on the left and one on the right. The one on the left we denote as f1. Once again, the focal point on the left of the convex lens is denoted as f1. There will be another one on the right that will be denoted by F2. Obviously, you will remember that OF1 and OF2 will be similar. The length is going to be same. So the focal length on the right hand side and on the left hand side is going to be same. It is not different, remember. Okay. So whatever is the focal length on the left hand side, same as on the right hand side. Fine. Similarly for the concave lens. So concave lens, you will have one focal point here that we will call as F1. The left hand side we call F1 and on the right hand side we call as F2. Okay. So the first thing, convex lens and concave lens, they have got two focal points, F1 and F2. Now you will ask, if it has got two focal points, what about the focal length? They have only one focal length. Once again, two focal points, F1, F2, but single focal length. Okay, the focal length will be measured on the right hand side for a convex lens. So for a convex lens, you will measure focal length on the right hand side, and for a concave lens, focal length will be measured on the left hand side. What are the reasons? You will understand when we are doing the ray diagrams. For now, remember. So therefore, for a convex lens, the focal distance, okay, is always positive. Once again, for a convex lens, focal length will be positive, and for a concave lens, the focal length will always be negative. Okay, so once again I will repeat, two focal points but single focal length. Convex lens, positive focal length. Concave lens, negative focal length. Okay, these things have to be understood because when we are doing numericals, these things are going to be of very much importance. Okay. Now that the construction of these lenses is understood, we are going to see the ray diagrams. Okay, and here are the rules for the ray diagrams. I hope you remember the rules for the concave and convex mirrors. Okay, so it is important to understand the rules. Now for the lenses, here are the rules. First rule is for convex lens. A ray of light that is coming parallel to the principal axis after refraction will pass from the focus. Which focus? F2. Okay, so all the parallel rays that are coming parallel to the principal axis towards a convex lens, after refraction, they will all pass from F2. So they will look like they are converging. That is why a convex lens is also known as a converging lens. Okay, so this is rule number 1 for convex. Second rule for convex. If a ray of light is passing from F1, after refraction, it will go parallel to the principal axis. Okay, simple to understand. If ray of light is parallel to axis, it will pass from focus. If ray of light is coming from the focus, it will pass parallel to the principal axis. Okay. Third rule for convex lens. If ray of light is coming towards the optical center, it will pass without any deviation. Okay, it will go in the same line. So these are the three rules for convex lens. Now here is the rule for concave lens. If ray of light is coming parallel to the principal axis, it will after refraction, it will move as if it is coming from the focus F1. Okay, I hope you can see it in the diagram. The ray of light is coming parallel to the principal axis and it looks like it is moving away from the focus. And which focus it is? The focus is F1. Okay, so if many rays are coming parallel to the principal axis, they all look like they are coming from the focus F1, and therefore a concave lens is known as a diverging lens. Okay, is that understood? Now second rule. If ray of light is coming towards F2, it after refraction it will pass parallel to the principal axis. Okay, similar to the rule for convex lens. Only thing in this case we are seeing the rays coming towards F2. Okay, So after refraction it will pass parallel to the principal axis. And third rule is the same, that if a ray of light is coming towards optical center, it will refract as if without any deviation. Okay, so it will refract in the same line. So I hope these rules are understood. Once again look at the ray diagrams. Okay, in the next class we will talk about image formation by concave and convex lenses. Thank you.